Hi everybody, I'm Mike Morgan, one of the woodshop safety monitors. I want to review for you today the safety procedures that we ask you to follow when you're operating our routers or the router table, which contains a router mounted underneath. Routers are just a high-speed motor with a chuck mounted in them that holds the cutting head. Router bits come in a very wide variety of shapes to allow you to cut virtually any shape you desire into the edge or side or center of a piece of wood. This particular bit, I hope you can see, is meant to cut a quarter circle radius around the corner of a piece of wood, and I'm going to demonstrate that for you later when I mount it in the router table. Okay. But you can see from this small collection here that there's a huge variety of router shape to choose from. Here's a dovetail bit, another dovetail, round over. That's a chamfer bit there, cuts a 45 degree, that's not quite 45, but a straight angle along the edge. Straight bits for cutting rabbets and dado slots. Any number of shapes are available. And we have drawers and drawers full of these. This one produces a bead shape with 2 or 3 bumps along the edge of a board. Some people like the looks of that on cabinet doors as an example. This is not always the case, but in many collections there's a drawing next to the bit that shows you the profile that it is going to cut. And when that happens, please remember to return the bit to the same place you removed it from so nobody gets confused. Once you've selected the correct bit, the first step is to insert it into the business end of the router motor. And of course, to do that, I'm putting my fingers in jeopardy. So the first thing I want to do is to make sure that the tool has been de-energized. Look for the bare plug. There it is. I can confirm that the tool has been de-energized. So our steps are to place the shank in the it's called a collet, by the way, not a chuck. Don't ask me why. So we place it all the way down, but that's too deep, and then bring it back up. And I'll look down here to make sure that I can see some of the silver part of the shank so that I know that the collet is not gripping that curved area right at the top. Then we'll hand tighten and use the wrenches to finish the tightening. And once again, please don't gorilla tighten it. Only needs to be a little bit tight, just snug. That way the next person doesn't have a terrible time removing the bit. And we're ready to set up the router for operation. First thing you'll need to do is to lower the entire router system to the correct height to cut the shape that we wish to do, and that's done with this crank right here. As we turn the crank, you can see the router dropping. The whole assembly goes down, and we will lower it until the part of the bit that we want to contact the wood is just above the table. And this has to be done by eye usually, and it's approximately at that point. Then withdraw the crank, and we'll return the insert now using this special wrench to snug it in place. Every router operation involves fixing either the router itself or the wood that you're working with. In the case of a router table, the fixed component is the router motor, as I've just shown you. It doesn't move. It rotates but doesn't move, but the wood can move. In addition, however, it's necessary to place the moving part, in this case the wood, next to a stationary surface throughout the process of cutting. In this case, it's this bearing mounted at the top of the bit. So that as we pass the wood across the cutting surface, the edge of the wood must be in contact with that bearing at all times. Otherwise, it's almost impossible to hold the wood in the correct position to get a smooth cut. So always set the tool up with a stationary surface of some sort. Many bits come with a stationary surface already provided in the form of this bearing. There are, however, bits with no stationary surface. In that case, use the fence. In other words, the fence must be set out at this point where the wood can be in contact with it at all times as it crosses the cutting surface. So fence or bearing, one or the other. When you get to be a very experienced user of routers, you can do what's called freehand routing without using a stationary surface. That's tricky, difficult to control, and potentially hazardous. So as I say, wait until you've got a lot more experience before you try doing that. The feed direction is important on any router, and to know which direction is correct, you must first realize that the rotational direction of the bit is like this when the router is mounted as it is here. So the cutting surface that you want to contact at the front end of the bit is moving in this direction. So the feed should be opposite to the motion of the cutting surface. So always feed from right to left on the front edge of the bit. We're ready to start the machine now, so first we'll open the blast gate to provide for dust control, and I can feel air motion there, confirming that we've got airflow in the correct direction. And then I'll energize the tool. And we are ready to begin. The reminder, the feed direction is always right to left along the front edge of the bit. And the on-off switch here is very nicely designed. This is on, and off is just push the paddle back in. On, off. And this beast has poor table manners. It's a very noisy eater. So I'm going to insert my hearing protection, and we're ready. And you see that I made a fairly nice clean roundover on that originally square edge. Notice that the router bit cut a very small furrow here, which is a result of having the bit set high enough that this front edge right here actually contacted the wood. To avoid that, I need to lower the bit just a little bit. The bit lowered just a little bit. Aha. But you can see the principle behind making this a nice rounded edge. Several other comments are important regarding your safety. I've been repeatedly saying that we must run the work along the front edge of the bit. Never run it along the back. In other words, never route this way, along the back side. For two reasons. One is you'll likely be pinching the work against the fence, which is a perfect situation for creating kickback. And the other is if you pass the wood this way across the back side, you're not inconsistent with that principle of keeping the motion of the wood piece counter to that of the rotation of the bit. So always stay on the front edge, never the back. Just a reminder that we did not use the fence with this last operation that I demonstrated because of the presence of this bearing, which serves as the stationary surface against which the wood is held. So while I was running the wood through, I was concentrating on keeping this edge of the wood against that bearing as it crosses the cutting head. For a bit with no bearing, we must use the fence. Imagine a bit with no bearing. We would set the system up this way and use the fence as a stationary surface and pass it across the bit in that way. Using the fence requires considerable care and setup. You've got to get it in exactly the right position in this dimension so that the wood crosses the bit where you want it to. So it takes some care to set fences up, but this is another good way to provide that stationary surface. Notice that I've left a gap here so that the bit doesn't cut holes in the fence board, but I want some opening here also for purposes of allowing for dust control. In my demonstration, I have been using a fairly large piece, and you probably noticed that I could keep my fingers well away from the bit. Always a good idea. In other words, not to do it this way, but to do it this way. A couple more safety issues. As with all rotating equipment, never start the tool with the wood in contact with the cutting surface. That's very dangerous, so always make sure that your wood is well back when you start the tool. And likewise, when you're finished with the cut, stop the machine and wait for the bit to stop rotating before you do any cleanup. Never get your fingers close to the business end of this tool while it is still rotating. There are 2 router tables in the shop, and so if one is busy, the chances are you can get time on the other. Occasionally it gets busy and there may be the need to coordinate with other users to make sure that they all get fair access to the machine, but in general, this has not been an issue so far. If you're going to do freehand routing, please let the monitor know so that she or he can work with you, find the safest way to do it, and monitor to make sure there are no upsets in the process. Router bits sooner or later become dull because they get heavy use, and it's often difficult to know when a router bit needs to be dressed or resharpened. You rarely have an indication that the bit is dull or needs cleaning or dressing unless during operation you notice that it burns the wood and you can smell it, or that it cuts more slowly or less cleanly than it did before. Those are clear indications that it's time to inspect the bit. Just a couple more comments on bits and use of the router. Here's an example of what's called a chamfer bit. Cuts a 45-degree angle off the corner instead of a rounded one. And I think it's pretty easy for you to visualize that depending on the height at which you set the bit, you're going to be removing quite a bit of material. And the more material to be removed, the slower you will need to feed into the router bit. So keep that in mind when you're going to one of these bigger bits. It also is necessary to slow down when you're using hardwood versus softwood. So routing maple requires slower feeds than if you're routing Douglas fir or hemlock. And sooner or later you'll acquire a feel for this because you can tell when the router is being overloaded because the pitch of the motor will drop noticeably. There's always some drop in pitch, but after a while you get used to knowing how much is normal and therefore how much is abnormal. If the pitch drops too much, you're removing too much at a time or removing it too quickly. Handheld routing would be operated like this with your hands firmly on the 2 grips of the router, and you'll set it against the piece of wood, again using a bit with a bearing. The stationary surface is the bearing of the bit, and the wood is fixed by our clamp, and the movable part is the router motor itself. The direction of rotation of the bit is shown by this arrow. So the motion of the router in this case should be counter to the motion of the wood. Wood is stationary, so the bit needs to move this way against the rotation. When removing the bit, realize that you're getting your fingers in close to the cutting edges. They're sharp as a knife, and so be very careful when you remove the bit, and I recommend wearing gloves, in fact, to avoid contact between your fingers and the sharp edges of the bit.